So expressions with letters instead of numbers. If we had a square that was 3 centimeters by 3 centimeters, we know that the perimeter would be 3 plus 3 plus 3 plus 3. We'd go from one side of the square and add up all of the sides one by one, which is the same as saying we take the number 3 and we multiply it 4 times. So this is the important thing here. We wouldn't actually often add those numbers 4 times. We'd just take the side 3 centimeters and we've got 4 of them, so we would multiply by 4. To get the area of the square, we know that we'd have to multiply 3 centimeters by 3 centimeters, which is the same as 3 squared, 3 times 3, which is 9 centimeters squared. So our perimeter for this square would be 12 centimeters and our area would be 9 centimeters squared. It's exactly the same thing if we put letters there instead. So if we say that we have a square that is a centimeter long and a centimeters wide, the perimeter would be represented as a plus a plus a plus a, which we wouldn't write like that. We would say that we've got a. How many times have we got a? We've got a 4 times. So we've got 4 lots of a as our perimeter. But the area would be the a length multiplied by the a length, which would be the same as a squared. So a times a in maths terms would be known as a squared. The perimeter in this particular case would be 4a. So getting used to manipulating with numbers and algebra. So if I have a string of numbers where I've got 1a plus 3a plus 5a minus 2a plus 4a, how would I do that? Well, in maths terms, we actually often never write a number in front of it if there is a 1. So instead of writing 1a, we would just write a. There is no 1 that we put there in maths. So then we just have to look at our string of numbers and say, okay, I'm adding up in a's, and I've only got a's in every single expression, so my answer is going to be in a's. Then I have to think of what is 1 plus 3, well that's 4, 4 plus 5, that's 9, 9 minus 2 would give me 7, 7 plus 4 would give me 11. So my answer here would be 11a. So when I've got a string of numbers, I just add up the numbers that I've got and then add the letters that I've got at the end. What do I do then if I've got numbers like this? A plus b plus 3a minus 2b plus 4b minus 3a. Well, what I do in this case is I look at the a's first and I simplify. I add up all my a's. So let's identify where I've got an a in front. I've got an a there and here and here. And then I just say, what is 1a plus 3a minus 3a? Well, I'm answering in a's, and I look at what is 1 plus 3, that's 4, minus 3 is 1. So my answer of a's is only going to be 1a, which I write as a. For b's, I'm going to have, I've got a b here, minus 2b plus 4b. Well, 4 plus 1 is 5. 5 minus 2 is plus 3. So my answer here is going to be plus 3b. So if you've got a string of different letters, you must treat them differently. There is no such thing as apple bananas. So you've got, if we've got a lot of different apples here and a lot of different bananas, and we add them all up, I've got 1 apple and 3 bananas. So you must keep letters differently. You can't put them together. Okay? Unless you're multiplying them. If we had had a times 2b, then we were allowed to multiply 1 times 2, giving me 2, a times b, giving me ab. So if you're multiplying in algebra, you can combine the letters, not if you're adding and subtracting. So what would 2a multiplied by 3b equal? Well, 2 times 3 would give me 6. A times b will give me ab. What would I do if I had minus 2a times 3b. Well, a times b is going to give me ab as the answer. Minus 2 times plus 3, that's a minus times a positive, which is going to give me a minus answer, and 2 times 3 is 6. So that would be my answer if I did minus 2a times 3b.